Okay, chapter 5.8, which covers the law of cosines and Heron's formula. And this video lesson, we're going to look at the odd-numbered problems 17, 19, 21, and 23. I think on the worksheet there are a few more problems beyond that. But anyway, we have a situation where we're given an angle and two sides without a drawing for problem 17, and what I'm going to do is kind of make a little sketch. Sometimes that's a really good place to begin. So if we draw this angle here is 47 degrees, and I try to make it somewhat accurate. It doesn't have to be, but this angle looks like it's about 47 degrees, maybe a little bit less. And we have angle A, and on either side are going to be sides B and C. So it looks like the long side here is going to be side B, which is 32 feet. And the shorter side will be side C, which equals 19 feet. And so here we have side A is going to be opposite here. So side A, we don't know what it is. So the first thing we're going to do is find out, we're eventually going to find the area of a triangle. We can find the area of a triangle using something called Heron's formula. But to get to the point where we'll be able to use Heron's formula, we need to find all three sides, unless we have a right triangle. Obviously, it looks like we don't here. And so to find this side A, we use Heron's formula, which, since we're solving for side A, we have A squared equals, I'll just write it out of the formula here, B squared plus C squared. And so far, we really have the Pythagorean theorem, and then the adjustment for the angle other than 90 degrees is 2 minus 2 times side B times side C times the cosine of this angle A. So just filling in, we have A squared, and B is 32, so B squared is 32 squared, and C is 19, so C squared is 19 squared, minus 2 times A, which is 32, times C, which is 19, times the cosine of angle A, which we're given as 47 degrees. So this will be it. And to find what A is by itself, we take this whole big thing and wrap it inside a radical. So we have the square root of quantity, 32 squared plus 19 squared minus 2 times 32 times 19 times cosine of 47 degrees. And going to our calculator, we see that we are set in degrees. I'm going to escape out of here, go to the calculator page. We're going to take the square root of, try to remember, 32 squared plus 19 squared minus 2 times 32 times 19 times the cosine of, I believe it was 47 degrees. Let's go, before we press the enter button, let's look at 32, 19, 32, 19, cosine 47, 32, 19. Okay, everything looks good. So we get side A as 23.5731, 23.5731. When I'm making calculations, I like to carry out as many significant figures as the calculator will give me. Reason for that is that your accuracy when you're making a subsequent calculation will diminish the more you round off. So anyway, now we can use Heron's formula. Heron's formula is a two-part formula which has, first of all, there's something called a semi-perimeter. The semi-perimeter S equals A plus side A plus side B plus side C over 2. And in the case of this triangle, we're going to have A is 23. Because of these significant figures, I'm going to just continue below here. S equals, we have 23.5731 plus, let's say B is 32 plus 32 plus side C, which is 19, all over 2. And let me move this over here. There we go. Create some room. Let's go to our calculator, find that semi-perimeter, and to do that, and the numerator 23.5731 plus 32 plus 19, and all that divided by 2. So that is our answer. And what I want to do is store this in our calculator to the character S. So I'm going to put control vars, which is STO, storage, and we're going to go to S. So right now the calculator has stored in it the semi-perimeter value. Is going to really make our next calculations easier. And we're going to store the values of the sides too. So we're going to put 23.5731 storage, control vars A, enter. The side, doesn't matter which side, I think it's side B, 32, storage, side B, enter, and 19, storage, C, enter. So we have quantities for S, A, B, and C entered in our calculator right now. And now we go back and we're going to put Heron's formula. And Heron's formula is the area equals the square root of S times quantity S minus A times quantity S minus B times quantity S minus C, S minus C, all that in parentheses. So we go back to our calculator, and to calculate our area, we're going to go control, have a square root, we're going to have S times. Now when you multiply by parentheses, a lot of times your calculator will give a error message that you're using text. So we have that first one. I'm going to multiply that, open parentheses, S minus B, okay, times, open parentheses, S minus C. I've also written a Heron's formula program that I'm going to show in most of my classes. Anyway, that's our area, 222.57 0.332 square units. So I'll put units. Doesn't give a actual unit, square inches or anything like that. Anyway, actually it does. Take that back. This is feet. This is square feet. Square feet. Okay, very good. Okay, now on to problem number 19. We have find the area of the triangle. Looks to be a similar type of triangle. May not work the whole thing here, or may. Anyway, we have angle B. Angle B looks like it's kind of a wide one right here, so I'll put angle B. We have 101 degrees, so that's going to be a little bit bigger than a right triangle. And then we have side A. We'll call this short side A equals 10 centimeters. And side C equals 22 centimeters. So to find the area, we need to find this side B, little b, which we don't know what that area is. Well, for this, what do we use to find our third side so we can subsequently use Heron's formula? Well, we use our law of cosines. So, the version law of cosines we're going to use to find side B is b squared equals a squared, which is, go ahead and write this, 10 squared, plus side C, which is 22 squared, minus 2 times 10 times 22 times the cosine of 101 degrees. And I didn't label this here. Let me put it over to 101 degrees. Okay. And to find what B is, we're going to take the square root of all this. 10 squared plus 22 squared minus 2 times 10 times 22 times cosine of 101 degrees. And we're going to do that right now. Take the square root of, let's see, it's 10 squared, I believe. 10 squared plus 22 squared minus 2 times 10 times 22 times the cosine of 101 degrees. And our answer for that is we get 25.8448 degrees. 25.8448 degrees. 25.8448. I said degrees. That's wrong, isn't it? We're talking centimeters. So now we have sides A, B, and C. So now switching to Heron's formula, we have S is equal to 25.8448 plus side, that's actually side B, and then side A, and then 22 all over 2. What I want to do is try to be a little more efficient this time than I was, at least with the calculator, than I was last time. What I'm going to do is I'm going to put this answer here, so I'm going to put to the last thing calculated, so I'm going to put control storage, that answer to, that's side B, isn't it? So B That's B. And then we have side A. I forget whether it's A or C, doesn't matter. 10 storage A and 22 storage C. And so we have A, B, and C stored. Now we're going to take, oops, I got the wrong one. Control, oops, escape here. Control division. We're just going to put A plus B plus C all over 2. And then if we calculate that, that's going to be our semi-perimeter, which we are now going to store to S. So I'm going to put control vars for storage S. So now we have all the elements. So again, just writing our formula, the area is equal to the square root of S, which is semi-perimeter, times S minus A, times quantity S minus B, times quantity S minus C. And all we have to do now, since we have S, A, B, and C stored, we can go to our calculator and put control x squared, and we'll put S times parentheses S minus A, S minus A, times parentheses S minus B, times parentheses S minus C, and here we have 107.979 square centimeters. 107.979 centimeters squared. So that's going to be our answer to problem 19. On to problem 21. Decide, exercises 21 through 28, decide whether a triangle can be formed with the given side lengths. If so, use Heron's formula to find the area of the triangle. Well, let's just go ahead and make this little sketch. Okay, we have side C, which is 8. So that's 8. C equals 8. And we have side B, which is 5. So we'll say B equals 5. And we have side A, which is 4. Now, the thing we have to look at is if the two short sides are equal to or less than the longest side, we know we don't have a triangle. In this case, we have feasibly a triangle because the longest side, 8, is shorter than side B and A added together, so it means we can get a triangle out of this. So we can go take our Heron's formula, which is going to be two-part formula, S equals, or semi-perimeter equals A plus B plus C over 2. So going, and then after we find that semi-perimeter, we have area equals square root of S times quantity S minus A times quantity S minus B times quantity S minus C. And then let's go do that again. Let's see, we have okay, 4, 5, and 8. 4, 5, and 8. So we're going to put 4 storage for A, enter. 5 storage for B, enter, and 8 storage for C, enter, and now we have we'll find our semi-perimeter by taking A plus B plus C all over 2, press enter. We have 17 over 2, and we're going to go control vars for storage. We're going to call that S. So now we have A, B, C, and S stored, so we can now go to our Heron's formula, which is S times, all I want to do is see what happens if we forget to put if we just put parentheses, show what happens, see if we get an error message. S minus A times S minus B times S minus C. So we have everything entered, press enter. Invalid implied multiply. Again, like I mentioned earlier, this is kind of an idiosyncrasy of the TI Inspire calculator, that sometimes if you don't put a division sign after the letters, which are variables the calculator thinks are text. So we're going to have to redo this, and for that I'm just going to place multiplication symbols in between. Let's see if it'll work just between. Yeah, it works. We had to put after the S. Looks like you didn't have to put the multiplication symbols between these sets of parentheses. The calculator, as you see, did this automatically for us. So we have an area of 8.18153, 8.18153, 8.58153, and it doesn't give units here, it doesn't give feet or anything like that, so we'll say units, whatever they are, square units. So that's going to be our answer for 21. And finally we go to problem number 23, which we have, again, the direction to decide whether a triangle can be formed with the given side lengths. If so, use Heron's formula. So we have oops, that's 22. Let's look at 23. 23, we have A, B, C. In this case, we have C is 8. So C equals 8. And we have B equals 5. So B equals 5. And we have C equals 3. No, A equals 3. Now in this case, we have C equals 8, and that is equal to the side A, which is 3, plus the side B, which is 5. And so really, we do not have a triangle, because it's impossible to get a triangle when you have B and A added together equal to side C. So we'll say a triangle cannot be formed. We have just a line segment. Cannot be formed. So make a little drawing and think about it, and we'll be okay. Anyway, this video lesson should help, I hope, with all the other problems in the set. And I thank you for viewing.